This is an indication of how few tools are required to build the airplane. We have wrenches, pliers, cutters, a couple of files, pop rivet gun, sheet metal shears, hole saws, and a couple of screwdrivers. It takes very few wrenches to accomplish. We have 3/8, 7/16, and 1/2 inch wrenches. We have a set of ratchets and sockets, the ratchet being 1/4 inch. Here we have a power drill. It's a portable battery operated pack. We have a 1/16, 3/32, 1/8 inch, 1/4, and 5/16 drill bit. Here we have a nice addition, although not totally necessary. It allows cutting of holes, such as in the ribs. Where you want to make an oblong hole, you can drill 2 round holes and join them with the sheet metal shears. This way you don't get tears and cracks at the corners. Here we have a Stanley power lock tape. It is not necessary to get that brand, but a 16-foot tape that is a stiff tape is more easily handled by one person. It does not have to be marked in millimeters either. Here we have a pair of pliers. They're standard pliers, and they're used to form and bend the sheet metal and straighten it. If you get too vigorous with it, you can also tear it. Here we have a pair of side cutters, or diagonal pliers, or cutters, for cutting wire, etc. Here we have a pair of cable cutters. There are different varieties on the market, cost-wise and quality-wise. An inexpensive set will do just fine for this operation. Two files are all that are necessary, one flat, one rat tail, the rat tail being used in corners and round areas, the flat for on flat surfaces. Handles are nice to keep from jabbing the ends into your hands. Felt tip pins are used to mark the sheet metal. Aluminum parts. We don't use pencils, we don't use ballpoint pens, because both of these objects will scribe a piece of aluminum and cause a stress point, which can eventually become a tear or a crack. A nice set of pop rivets, well, a pop rivet gun is nice. You can use an air-driven or a hand gun such as this. There's not enough rivets that you would have to buy a really expensive piece of equipment to do this. A pair of tin snips are good. I like to have a left cut, a right cut, and a straight cut pair of shears. It's not totally necessary to have all three. One good straight pair of shears can be made to be used. Here we have 2 screwdrivers, basically all that's necessary for the entire kit. Occasionally you might want to have different sizes, but we have a Phillips here and a flat bladed screwdriver. That should be sufficient in most cases. What we're after is to keep the cost down. Here we have a Whitney hand punch. This is very nice in punching holes in the ribs for the rib stitching. pop rivets. They can be used in several places, but that is where I like to use them the most. We've relieved the end of the tool so that it will fit up and punch a hole directly in the center of the rib flange, not towards the edge and not towards the vertical piece of the rib itself, but right in the center of the flange. This way you can keep it from tearing out. Now this is a punch that can be changed from size to size, so it can be used in many instances, many different cases. It's much easier and much nicer than drilling a hole with a drill bit. It also has a gauge that allows you to stop your punch in exactly the same depth if you're going to punch multiple holes. This is a chalk line, and we use this by marking each end of the rib or wing, a rib on each end of the wing, and then having a partner hold on one line, you hold on the other end, and it makes a very straight line of rivet holes. It marks the spot you punch or drill later, right on that mark. Makes a very neat looking wing when you can see all the rivets in one row. Here we show a man laying out the wing spars for the rib locations. He's got the front and the rear spar laying side by side, and starts at the butt end measuring all the rib locations, and then with a square marks them in a straight line. You want to be sure you build a right and a left wing, not two rights or two lefts. Here Victor is deburring the sheet metal. You must take all the burrs off and polish them, polish the edges. This will ensure that sometime in the future, while you're flying or over a period of years, you don't get cracks in the sheet metal. So deburr all edges. This is a lineup of parts on a table where we've inventoried. They've been painted, deburred. All the parts are in a kit. You lay them out so that they can be identified. If you have to dig through a box to find every part, then it's very time consuming and exasperating. Here the ribs have been slipped in place on the spars into their approximate locations. They're not riveted in or screwed into place at this point until the drag anti-drag wires are connected and the spars are trued up. We first put the fittings in, the compression tubes, and then the cables. Here we show the drag anti-drag cables and the leading edge going on. This happens to be a full D-cell leading edge. You start on one end of the rib, or one side of the wing. This is the bottom of the wing. Now what Victor has done here, he's taken a felt tip pin and marked right down the center of the ribs. He's pre-drilled his skins, and you can see him moving the rib over so that he can see the center line. He can see the center line on that rib through the hole. Now he will transfer the hole into the rib. You get perfect alignment this way. Now he'll take a cleco and cleco the rib, or the rib and the sheet metal in place. It won't move. He will leave these clecos in case there's a mistake. once you put the rivet in and you have to drill it out, you'll oversize the hole 90% of the time and make an improper fit. So use Clecos if possible. Here's an overlap in the skin, but he's doing the same thing. He's got holes drilled in both skins. He aligns the rib, transfers the hole, perfect alignment. I ran out of Clecos. This shows the leading edge skin drilled with 3 32nd holes for attachment to the spar caps with number 4 sheet metal screws. Alright, this is a shot of the main spar, inboard in, and this is the fuselage attach point, fuselage attach brackets. The round spacers in this area are to space the brackets out. They're on both sides of the spar because this is a thin web in this area with a spar cap up here, and this is to get these out to proper width. You'll notice on the bottom here that there are no spacers. We have a large area washer in these areas in order to distribute the load evenly over a greater surface, thereby not weakening the web itself. These are the main spar attach brackets. Okay, these are the main spar attach bracket here, and you can see the I-beam structure of the spar and why it is necessary to space these brackets outboard with the little round bushings or spacers that we had before. Go ahead. Alright, these are the main spar attach brackets. You can see the I-beam of the spar, and the reason that the round bushings are used in order to space the brackets. They're necessary in this area. Now this is an illustration of how a cutout on the first 8 inboard ribs of each wing needs to be made. Although this is not the best way to do it. I don't know who cut these out, but the little round hole saws that we mentioned earlier in tools would put a nice round hole here, a nice round hole on the bottom, and the holes could be joined and make a very neat, smooth hole. This is an illustration right here in this corner that you want to avoid. This is the beginning of a tear in the aluminum. If you have round holes, you don't get that. Here's another area and another area. These 2 points here. This is to be avoided. Now, one way to stop a crack of this type is to drill a stop hole, which would be about, well, at least 1/8 of an inch in diameter at these points, at the end of these cracks. That will normally keep it from extending any further. If you wanted to make square holes in this area, you could drill round holes in each corner, then join them to make a smoother setup. But do not cut square. I want to stress that you need to look at the drawings. The drawings are not shown like this. And all of the points that we're going to mention are in the drawings. We're only doing this on video to help illustrate the proper way to do things. Everything is shown on the drawings. Okay, here we are on the outside of the main spar. We have main spar attached brackets again. The spacers. You'll notice the bolts are facing aft. The nuts are on the aft side of the bolts. And this is standard aircraft procedure. All bolts go aft, down, or inboard. And this holds true except when it won't work any other way. Then you do it the other way. This is the compression tube.
What does that do?
This maintains a parallel structure of the spar network.
Meaning keeps them a uniform distance apart?
That's correct.
Keeps them from being drawn together by...
That's right.
Stuff.
Now, when we hook up, we'll show later our drag, anti-drag wires, which are cables, which cross diagonally and keep everything square. The spars are held parallel with these struts, so you've got a box network, like a box kite, and it's very strong.
Ah, box kite, good.
This apparatus are cable guides. They're out of Delrin. They're very abrasive resistant. The cable wears backwards and forwards on it. And of course it's spaced out to get the proper distance from the spar web. Okay, these are stiffeners. They're actually very light sheet metal, but they do a very good job of stiffening the rib in the center area between the spars, and they're attached with a pop rivet on the spar web close to the top, and again close to the top of the rib. Now there's an identical stiffener at the bottom. Now what these do are to aid in preventing this area of the rib from pulling in when the fabric is stretched. You have to have, there's too long a span between the spars in order to or to keep from pulling it. So something has to be done, and this is the answer. Now,
I'm wide now.
okay, if we come back to the rear area here, we have an identical spar top, stiffener, top and bottom, that goes to the rear spar. And with the little triangulation here, it does a very nice job in stiffening the rib. Okay, here again we have spar attach fittings, and this is the inboard end of the rear spar. Again, we have the spacers on both sides of the spar. Again, the bolts are facing aft as standard procedure. This is the rear attach point, a fuselage attach point here. And here's the exception to the rule, where you have to turn the bolt forward and not aft. It won't work any other way. Okay, we can go on out.
We're coming out.
All right. Here again we have another stiffener. We have one in this area because it's relatively small, a relatively small area in the center of the rib, halfway between the spar and the trailing edge. Again, this stiffener is put in place to keep this area of the rib from pulling inboard, or outboard in this case, in this direction when the fabric is tensioned. It just takes one pop rivet on each end. And all these are angles. They're mashed on the end and bent to the proper angle. Okay, this is the left wing, rear spar, and a jury strut attached bracket. It has 2 bolts in it right now in the spacers, and the bolts are not tightened up. You have one on the aft of the rear spar and aft of the front spar. That's very important. Our jury struts are made up in jigs, and if you happen to get one fitting on the forward edge of the spar, then it won't work. And it's very disheartening to get a wing covered and then find that you've put a bracket in the wrong place. So both of these, the aft and the front one, are on the rear of the spars. Now I'm going to tighten up these bolts, show you how.
Yeah, just keep going. This is working fine. How do you know when they're the right tightness? Do you use a torque wrench, or is there a rule of thumb?
Well, I use a small ratchet, as you can see, and you want the bolt nice and snug, but not overly tight. You want it firm. If you put too much pressure on these little bolts, you're going to break them or strip them. Actually, you won't break them, you'll strip the threads on the nuts probably. But now I'm going to put, just as an illustration, about what I would. Okay. It's a matter of feel.
Well, it's about 1 grunt.
There.
Maybe a 3/4 of a grunt.
Yeah. Since I have such a sharp lever on here, it's rather hard to put enough on it to really do damage unless you really try.
So that's a good reason why they should use the little socket wrench sets and not substitute a gigantic one.
That's correct. Okay, this is the inboard aileron hinge. It's the main aileron hinge. It attaches to the rear spar. Again, the bolts are aft, facing aft. They've got the spacer. Yeah, this is the aileron bay area, the innermost rib of it. And this angle runs the length of the bay from the inboard rib out to the tip, and is screwed on with tiny screws. They're 1/4 number 4 sheet metal screws. You drill a 3/32 hole and screw into that hole. It comes out perfect to hold. It's up nice and as flush as you can get with the rib flange, and what it does is allow the fabric a nice flat surface spanning between each rib so that there's no sag. And then the fabric comes over and goes down to the bottom of the spar. Okay, this is, again, is the inboard aileron bay area, and we have a span from here to the trailing edge, which is relatively broad. Again, we need to put a stiffener in this area to keep the fabric, when shrunk, from pulling this rib in and distorting it. Be sure when you put these stiffeners in that you use a square to square these ribs up. You get a nice square bay area and a nice square inboard rib area that attaches to the fuselage. Okay, this is a bay in the aileron area of the wing. The front spar, of course, is the furthest spar away from us, the main spar. It's got the main strut attached straps that go diagonally down towards the bottom of the fuselage, and we attach our struts to them. It also shows the cables running in front of the straps. It shows a compression tube attached between the main spar and the rear spar. It shows the rear strut attached straps in the aileron bay area. And you'll notice on the drag anti-drag bracket on the forward spar that there are no drag anti-drag wires hooked up yet. We will go through that in a different sequence and explain how they're hooked up, tensioned, and why we do it that way, and one of the simplest ways to do it. Okay, here's the rear strut attach strap bolted to in the aileron bay of the rear spar. This is the compression tube attach bolt and the large surface washer that protects the web that we mentioned before. At this time, I'd like to mention a requirement of aircraft standards, which is that all bolts must have at least a 1.5 threads to 2 threads showing beyond the end of the nut. Okay, since the bolts they come in 1/8 increments, sometimes it is hard to get the proper amount of thread showing. You want the free span of the bolt, or the shoulder of the bolt, to clear any parts that you have as closely as possible. You don't want the bracket riding on a threaded area. So the way to do that is if you put a bolt into place and a piece of the bracket rides on the threads, you would need to go to the next size. That would be an 1/8 inch larger. Now, what's going to happen, you're going to need to take up the excess space so that you won't have but a couple of threads showing on your bolt. And AN standard allows that you can put as many as 3 washers on a bolt. You can put one on either end, under the head of the bolt and under the nut, or you can put them all on one end.
Doesn't matter then.
Doesn't matter. You can put up to 3 washers under the nut or 3 under the head of the bolt. Doesn't matter whatsoever. Okay, this is the aileron pulley bracket showing the top pulley. This is the top of the wing. This top pulley fits on top of the bracket. The lower pulley fits on the top of the lower flange of the bracket. It's a channel, actually. These little aluminum pieces are cable guides, and what they do is prevent the cable from popping out of the cable pulley inadvertently. In other words, you can disconnect the cables, let them hang loose, and then pick them right back up and they'll be right in place. They fit rather snugly along the edge. However, the pulleys do need to travel freely. That's something you want to check on this. Now, the top cable goes down and out of the skin of the wing at about 15.5 inches from the rear of the rear spar. That'd be forward of the rear spar. You would cut just a notch in the fabric about 3/8 of an inch long, just enough to get the thimble through, and put the top cable through it after the airplane is fabric. The lower cable comes almost straight back horizontally. They pass each other, and there's good clearance here, as you can see, and goes through a hole in the center of the rear spar. That goes to the, both cables actually go to the aileron hinge mounted to the aileron spar for that purpose. Okay, this is a shot showing the lower cable from the aileron cable pulley bracket going through the hole in the rear spar to the aileron hinge horn. Because the drag anti-drag cables are swedged permanently in place on them after they are installed, we need a tensioning device that enables us to put the proper tension on the drag anti-drag cables, and this little apparatus is the answer. The chain's 36 inches long.
And is there any special kind or weight or size?
It doesn't make any difference. Of course, the smaller chain is better because it won't sag as much while you're trying to use it. Okay, the S-hook has been pulled together where it attaches to the chain, so it's permanently attached. The other end of it allows it to be hooked into place when used and then disconnected easily. Okay, this is a common hardware turnbuckle. They're very inexpensive. In fact, this whole setup is very inexpensive.
How many of these do you need for building an airplane?
You need at least 2. You can get by with 2, and if you want to rig the whole wing before you crimp any terminals, you would need 6.
6
because there are 3 bays in the ultralight, or 2 places.
So that would be 6 lengths of chain, 6 S hooks, and 6 turnbuckles.
That's correct. All right, now here is a finished swedge and cable end, which has been used to make a drag anti-drag wire. We've got a thimble, a NICO sleeve, an anti-kink, which prevents the thimble from collapsing when a lot of pressure is applied. You can hear that. And the actual drag anti-drag fitting in this area. This is a compression tube. Okay, now on this end, this bay has not been tensioned yet. So what we do is to begin by swedging the cable, finishing it off on one end, and running enough cable to the other end of the wing to the other drag anti-drag bracket, the other end of the bay here. Now, so again, we have the thimble, never kink, the cable running around it, and a swedge. Okay, now here's the other end of the cable. It comes around fitting, around the thimble, around the never kink, just like the other end, and goes back through the sleeve, the NICO press sleeve.
What's the name of that bracket it's attached to?
This is
Does that have a specific name?
anti-drag bracket.
Anti-drag bracket.
All right, Then the bitter end of this cable runs out and gets a loop. It's not critical as to how far from this point that the loop is made in the cable.
Because that's just a temporary loop,
It's
right?
a temporary loop. It's going to be cut off after this part is wedged into place. So it's a means of getting your turnbuckle hook into a point that'll hold.
Right, and you were just pointing to the open hook on the end of the turnbuckle on the end of the chain.
Right. So
Right.
all you have is a loop. Now this, in order to keep the loop in place, these are reusable, and it happens to be called an electrical grounding clamp. Okay, now I'm using this at the moment to keep this from rotating, to help me hold it. I just don't have enough hands to do it. I'm going to hold this end of the turnbuckle, and I'm going to tighten the turnbuckle. I'll go from this side to the other opposing side so that I get both even as I can. Now at this point, when we think we've got enough tension on both cables, we go back to our measuring process and measure diagonally from spar to spar. And when it is square, on this end we've got the other two bays squared and NICO'd into place. Then we will NICO the final end on this bay, and the whole wing will be square. What we're going to do now is to square the spars. The compression tubes hold the spars parallel to each other. Now we're going to square each bay. There are 3 bays of drag anti-drag wiring setups. So in order to do that, what we want to do is go to the extreme inboard end of the spar, and using an arbitrary figure, which I'm going to use 2 inches here, I'm going to put a mark on the spar at that point. I'm going to go down the spar and make another mark at intervals to coincide with the bay areas. In other words, just use what you got. Each bay is about 55 or 56 inches in length. So I'm going to go down and say, I put one here at 2 inches. I'm going to go down the spar and put another mark at 56 inches.
Okay.
Okay, now we're going to square this mark.
I can see the mark and the line you drew and everything.
Okay, now we're going to bring our tape back into use. I'm going to make a mark on that original line right in the center. This is about 3/4 of an inch, so we go to 3/8 and make a mark. That's the exact center of the spar at 2 inches from the end. We'll do that at 56-inch intervals from this point on the front and the rear spar. And this will give us points in which to use to square the spars and wing areas. Now burn an inch on that end, it's easier to read. And this reads 60¼ inches. Now, we will go to the opposing sides. Can you pick that up?
You can reach it? Okay.
Yeah, I can reach it. If you're burning an inch again,
Well,
I'm reading 60¼
here all I'm seeing is the middle of the thing, but I think the idea will come across.
Okay. So I'm reading 60¼ inches again, which indicates that these spars are perfectly parallel and perfectly square. Now we're going to
Great.
find out what the tension is on this cable by deflecting it 1.5 inches, which is about there. And can you read the scale?
Mm-hmm.
What's it say?
5.5 pounds.
Okay. We're not quite there. So there we are.
7.
Okay, we want at least 6 pounds at a deflection of 1.5 inches. If the cables cross, we don't want them to chafe from vibration. So they can either be wrapped with leather, they can be wrapped with tape to separate the 2 wires. But in this case, we use 2 tie wraps. One is fastened around one of the cables. The other one is run through that tie wrap and fastened around the top cable. And they're tightened and the excess cut off. Now, what this does is put 2 pieces of tie wrap material between the 2 cables. And it lays right there, holds them in place, and keeps them from abrading. What we're doing is marking the outboard and inboard ribs for rib stitching holes, which are 1/8-inch pop rivet holes. We begin by laying out the hole positions on the outboard rib at the wingtip. We burned a foot here on the tape in order to let it lay down a little bit so that you can tell what's happening. The first hole is marked.
Yeah, go ahead.
At 2 inches from the aft side of the leading edge skin. Now this is on the top of the wing. So our first mark is at 2 inches. The second mark is 3 inches beyond that one. And then from there aft, the spacings between centers of holes are 4 inches. Now we mark the outboard wing rib. We go in and mark the inboard wing rib. Then we will show you how to pop a chalk line between them, and you'll have perfectly aligned holes if you drill holes in those locations marked. This is the top of the wing with 2, 3, and 4, 4, 4, 4, 4. The underside of the wing is 2 inches, 3 inches, and then 5-inch centers the rest of the way aft. All the sharp edges of the aluminum have been taped so that you can protect the fabric from abrasion. The end ribs have been marked for the pop rivet holes, or rib stitching holes. And now we have one person on one end of the wing at one of the points, and I'm going to pop a line with a chalk line at each rivet point. What this is going to do is transfer a mark on the top of all the ribs in a perfectly straight line so that we can drill holes through the ribs for the rivets.
Still rolling.
Okay, the reason for punching and rib stitching the fabric to the ribs is to maintain the airfoil. When you're moving a wing or an airfoil through the air, there's a negative pressure on the upper side of the wing which tends to pull the fabric up.
Mm-hmm.
And if it's not anchored down good, then you will deform the airfoil and screw the whole mess up.
Maybe you actually tear the fabric off.
It could tear the fabric off, but it would change all the characteristics of the flight.
Didn't do it.
Okay, this is a pre-cover assembly where you assemble everything, drill all safety holes, etc. And
Can we put the pin in?
Well, the only problem is it hasn't been, yeah. Okay.
That's okay. We can see what it is. That looks good.
Okay. Everything on the airplane is assembled, all the cables, etc. are joined. Then that's to make sure that nothing interferes with anything else. There's no abrasion points on the cables. And then it is disassembled and covered. When it's painted completely, then it's put back together. This piece here is a bracket which attaches the leading edge of the stabilizer to the airframe. It is held together with two bolts. Called out are in the drawings are AN3-12A bolts. However, that is when a spacer is used between this bracket and this bracket. In other words, if you put a 3/16 inside diameter bushing under this plate, you can actually raise the leading edge of the stabilizer or lower it by decreasing the height of the bushing. So we found that many times this is a very good place for the airplane to fly for trim.
Yeah,
and this takes when you bolt it flat down like this, it's an AN3-4A bolt. Right. Okay, we're using a stiff straight edge in order to align the elevators perfectly before we drill the points, the attach points. They're held on the C clamps, or it could be taped on any convenient way, but they have to be very accurate because you don't want them misaligned.
Tell me when to go in.
Okay, now we go into the bolts?
Yeah. Want to go in now?
Yeah.
Okay, yeah. Go ahead.
Okay, now here are the two bolts. We've already drilled them in this case, but once we've got the elevators hinged, the hinge pins in temporarily, and the elevators aligned and held in place, we can drill these two holes for these AN3-10A bolts. They're drilled undersized with a 3/32 or any 8 inches as far as that goes, and brought up gradually to 3/16. It needs to be a close tolerance fit so that you don't get wiggle from one side of the elevator to the other. It's a point that could fatigue if you don't do it close. At this point right here, these rear stabilizer spars go into this carry-through tube, and they're held in there by the cables. There's no reason to drill that tube. The cables, flying and landing wire cables to the outboard ends of the stabilizer will keep that in there close. It won't allow it to move. So here we are setting up the fuselage and tail feathers for the flying wires. We've got the outboard ends of the flying wires all swedged with thimbles and never kinks and knuckle press sleeves. That saves us a little bit of time and effort. Now we're going to attach the inboard ends.
Identify what we're looking at, if you
Okay, this is the flying wire attaching points on the starboard upper horizontal stabilizer. It's got an AN3-12A bolt in it, AN365-328, I guess, nut. Okay, this is the upper starboard horizontal stabilizer flying wire attach point.
Very good.
We've already got the cable swedged on the outboard ends. You can see this one.
Good.
And that allows us to work with fixed points before we ever get to the airplane.
What's the bolt and nut again?
The bolt is AN3-12A bolt, and the nut is AN365-1032 nut.
Okay. We ready to go up top?
I think so. This is the vertical stabilizer, or the upper part of the stabilizer at the upper end of the flying wire attach point. Again, we have the thimble, nickel press, sleeve, and never kink through the flying wire tab. Now, since the other ends are completely fastened, what we're doing are making fine adjustments on the upper end so that the horizontal stabilizer is perfectly level with the fuselage. We've leveled the fuselage top longerons, off the top longerons, which are supposed to be level. And now we want the vertical fin perfectly vertical, and we want the horizontal stabilizer perpendicular to that. So now we can put a level across the horizontal stabilizer ribs and adjust our cable on this end only by pulling or loosening this point and drawing the cable until we get the right tension on it.
Okay. And these are the same adjustable slotted electrical ground nuts and bolts that we used in the wing.
This is a nickel press tool used to crimp the nickel sleeves on the cables. Here we have the cable bushings inserted into the cable guides. We use a pair of vice grips to press the Delrin into the guide. Before anything is covered, of course, you want to assemble the whole airplane. One very important part is to put floors in your wood seat bottom and back. What this allows you to do before you cover is to transfer holes to the mounting points. We merely go in from the bottom, the mounting tab, and drill each hole. And that'll permanently locate that so that you can drill the rest of the holes and it won't move. Well, here we have the attach points for the fuselage stringers. They're 8-foot stringers listed on the parts list. They're set down in the little tabs at 4 points along the fuselage. A hole is drilled through the tab and through the stringer, and either a cotter key put in it to hold it, or a piece of safety wire, like a double wrap of safety wire through the hole, twisted, and then turned so that nobody will stick their finger through the turned end. Now, as the top stringer comes back here, if we let it run alongside the vertical fin and mark it, then we can trim that so that it will fit nicely along the vertical fin as it curves. That allows the fabric to blend well into the vertical fin. The cotter pins are cut off. They're normally a little longer, depending on the length of the cotter pin, and then formed over to anchor the stringer. The fabric holds the stringer in place forever. Once you have it in position here, there's not a great deal of strength that is required because the fabric shrinks down tightly over it and it will keep it there. This is the front attach point at the cabin area, and the top of the stringer is flush with this cross member here. Now, you'll notice right here, this tab on this side of the stringer doesn't come back far enough to engage for the cotter key to go through. But this is common, and it is merely a locating flange on this side, and the flange is drilled on the other side and is holding the cotter key and stringer. So that's all that is necessary. Okay, this is the front right hand end of the stringer, or stringer at the front right hand mounting point on the fuselage. This fitting back here behind this tube is the rear spar attach point. This will give you an idea of where the location is that we're looking at. Now, here again we've got the stringer between the little flanges, a hole drilled through, and a cotter key bent. Again, it is fairly flush with the top carry through. Here we have the instrument panel mounted in place with clecos. We have mounted to the flanges that are welded to the airframe. Now here are the flanges on the back side of the instrument panel. There are 4 of them, and we'll just temporarily hold them here till we have all the skins in place. Here we have a shot looking aft from the engine compartment. We have the firewall, the tank in place, and the instrument panel. This is a cardboard template used for a pattern that can be later transferred to sheet metal. We have a hole for the tank neck and 2 holes for the diagonal braces of the fuselage. Okay, we've cut the slots, the holes open. The big hole for the neck of the tank is actually locating the piece of paper. We have drilled a hole approximately 7 inches from the center of the hole aft, and clecoed the skin in place to the instrument panel in order to keep it located and to hold it right steady in place. All right.
Yeah, a note here. In this particular case, this cleco, the tab that this cleco is attached to is just a little bit off center, and therefore that's why it looks the way it does in the shot.
It's about 3/8 of an inch off center, and
this
that happens to be that there is a flange in the, or right directly in center, and the center line is directly between 2 flanges on the instrument panel. So you would have to go either direction from the center line to get into those flanges for location. Okay, now we want the sheet metal to fit in place without touching any steel parts. So I'm going to go in now and indicate with a pen, felt tip pen, where I want to relieve the sheet metal. Now again, we don't have to be super accurate. We can cut a larger hole and then fill it up. Okay, we're still working on the template. We're going to use the firewall and the instrument panel to lay out the cuts where we're going to cut this template. We'll have to do this probably several times before we get it right. We want to do it on paper though, and save that sheet metal. The paper costs very little. The sheet metal a bunch. So do it accurately. We're going to go right down these flanges now and mark them, and we should be ready to take it off and make our cuts. Okay, we've pulled the skin down now, and we're using a simple tool that's available in most households, the common clothespin. They come in handy for covering and for this type of job. What we're going to do is cut the lower part of this pattern, and we run approximately parallel and flush with the bottom of the top longeron. And we're using the aileron gap seal as a straight edge. Okay, now we're going to mark our cut line.
I guess.
Okay, at this point, we've got the skin about measured, but it's in place. Rather than take it off, finish it up, put it back on, and repeatedly. While we've got it where we want it, I'm going to check the top slope from the instrument panel to the front of the cowling to make sure that there's no breaks in it. The smoother it is, the better lines the aircraft have. And I'm going to put the cowling right up here. The bottom cut on the cowling is the center line of the prop hub. So I hold it right there and sight down that top, and it really looks good.
Yeah, can you let the front go down a little? Is there any way you? Yeah, okay. That looks even better.
Okay. Well, you've said that, but the center line is right there. So in order to fix it, we would have to let the instrument panel come forward enough to lower the back edge.
I see.
This is a fixed point here.
Okay. Yeah, Hollywood started. There you go.
This is a pair of lever snips, and either right or left, you can get both sides. This one cuts straight and then curvatures one direction. The opposite would cut straight and curvatures to the other direction. Well, the important thing is that the lower part be brought all the way up at the bottom, here against the bottom of the fuselage, because it takes that to make the top come down and fit well.
Okay.
Then we line up the front around here, and there's a groove in the lower half that the top sits down in, and that works just fine. So
Okay.
you Cleco those in place after you have the bottom in place.
Then you should have 1, 2, 3, 4, 5, 6, 7 Clecos on each side.
Yeah. And you want to make sure the prop hub cutout is centered, and that this line here, the joint line, is in the center line of the prop flange, and you have some clearance. If you get it centered, you'll have nut clearance.
Yes, correct.
Between it and the hub,
Okay.
because it's cut to allow that. It's cut in a circle. Now, here the rear or the top half of the cowling is oversized, so we have to cut it to that cutout, which means measuring up from the bottom and then marking it in place with a straight edge.
Okay.
Now, the rear has to be cut off too, so I'm going to now use one of the pieces in the kit. I've measured in back here to the vertical member of the behind the firewall member, or behind the firewall, and that's where my mark is. clecos are drilled into the flange of the firewall.
That vertical line should be parallel with what line?
Well, it's parallel with the vertical member of the fuselage between the longerons. It's the most forward vertical piece in the fuselage.
Okay.
It can go even to the center of that tube, but cannot go beyond that forward without leaving a crack. So now we've measured in at the bottom. We know this is about right because I can just barely see the tube at this point. So I'm going to run a straight line between those two. And I'm going to carry it right on up and around. So we're using a flexible piece of material. We fudged just a little bit here and there. Make it work.
I'll leave it here for her.
I'll do the bottom first. Seems like that's going to work.
No, straight up.
I'll take my pen,
All the way,
belt tip,
because it's about a 10 or 12 hour drive.
and mark my vertical edge where I want to cut it off. Now I'm going to move up, and by fudging just a little bit, because you have a radius, trying to go around the radius, I'll mark to a point, and I'll carry it right on over the top of the fuselage. To the center, and I'll go around to the other side and do the same thing.
Okay. Just take a bunch of this.
That's going to be trimmed off, sanded,
Type 1 to console.
and finished. The top half of this cowling, the bottom half is a pattern that I'm lucky enough to have. We've sent a drawing with the proper cutouts. These are not even the proper cutouts, but I'm using it as a rough pattern. We've sent a drawing that shows the proper cutout locations. It can be transferred directly on to the piece once you have it located and trimmed. Okay, this is a tool that you can make at home. This happens to be Delrin, but it can be made out of a piece of plywood or a piece of solid wood, and it is about a 1/2 inch thick. It's about 2 or 1.5 inches wide here. Comes down to about 5/8 at this end, and it's tapered, of course, to get to that point. And then a saw cut, a hacksaw blade, is used to get the depth of the, can you see this?
Mm-hmm.
The depth of the bend on the part. Now we have to use this on the firewall and the instrument panel. This is the instrument panel. So that depth of cut is cut into it with a hacksaw. For such an inexpensive homemade tool, this can really do a nice job. We get the same depth before the bend it 90 degrees. It just does a super job. Real neat and professional. The cabin roof comes in one rectangular sheet. It's normally indicated with a marks or belt tip pin where the cutout will be for the window area, windshield. This is a piece that has been cut out of another sheet.
Great. Contrast is beautiful.
Close there. And the other part of the roof, cabin roof, is a right and left cabin rib. They're already cut out. Now everything needs to be deburred. This is one way we get by the build so much in the airplane for the customer and get through the 51% rule. It can be done one of two ways. First, you can put the ribs in place on the fuselage without riveting. There's 4 tabs for each side on the fuselage to be attached, pipe riveted to the cabin rib. So you can put it in place, mount your wing, adjust to allow the wing to slip under the wing skin. You have to have a little clearance all the way around the wing, and then put the rib in place, pipe riveted in place, drill it, pipe riveted, and then put the skin on in place. You can remove the wings to do that since you have the ribs, locating ribs, already attached to the fuselage in the correct places, both right and left. Now, when you rig before covering, this is the way that it probably should be done. Once you've got a couple of points mounted, then it's easy to take apart and do it on the bench. Now, the way I just did this one was to measure the width of the fuselage at the rear of the cabin. That, in other words, the ribs have to go against the fuselage, but on the outside of the structure. So we measure the distance at the rear, we measure the distance at the front. It's supposed to be 24 inches. However, anything can move during welding. You don't know which way it's going to go because the heat applied. So we measure the front, the back, and say it is 21 or 24 and a 16th at the front and 23 and 15 16ths at the back. There's an 1/8 inch difference. So you find the center line of this skin by measuring and then you measure, this being the front, you would measure from the center line to, let's say I said it was 24 and a 16th, so you'd be just slightly longer than 24 here, slightly longer than 24 here to make 24 to 6, excuse me, 12 and a 32nd if you're going to be accurate, and 12 and a 32nd this way to give you 24 and an 8. Now this would be then the inside of the ribs where they mounted, flush with this inside surface. This being the left-hand rib that you're seeing here. The flanges go out for it. Okay, now I do the same thing on the other side. We found the inside of the flat surface of the ribs. Now, we go halfway from this across the flange and make a mark with a felt tip pin.
Again, the importance of felt tip only.
That's right. And we go all the way around the rib at that distance, marking a straight line. Now, the importance of this line is the fact that we're going to come in the same amount from these lines we've established out and make a parallel line from one end to the other for a rivet line. Then we'll mark off 3-inch spaces starting at the rear. That would be the other end. We will mark this drill line every 3 inches. Well, we'll come in a 1/2 inch first and then mark every 3 inches until we get all the way to the tip. We again be a 1/2 inch from the edge, front edge.
If you're lucky.
Well, it won't work out exactly, but if everything else is symmetrical, then it won't look bad. It'll be fine. Okay, so we've got all of our holes punched or drilled on both sides for the ribs. Now, if we lay a rib up with the rear edge flush with the rear edge of the skin, and we look through one of the drill holes, the first half-inch drill hole, and line the mark up that we've got around the center of the flange
Right?
of the rib. We can hold it there and drill our first hole, cleco it, and we can work all the way around both sides that way. And when we get through, the two ribs with the turtle or the roof on it should just drop down over the fuselage sides. Then with the wings in place, once you drop it in there, slip the wings in place. You're going to have to rig it anyway and locate your roof. Okay, the windshield glass comes protected with either paper, gum-back paper, or a plastic sheet. This one has a plastic sheet on it. And we take a pattern that we have and mark the approximate lines of the cuts.
That's important, approximate.
Do not cut this piece of material until you have a pattern, because if you do, 99% of the time it won't work. At this point, this was traced off of a pattern. I mean, such as the approximate layout on the glass.
Now, does that mean you took this piece of materials, laid it on this red thing we were looking at, and kind of traced these lines?
That's right.
And then cut those lines on the paper pattern,
Just
not the plastic.
You know, just cut it out. You can use poster board, and you can waste 3 or 4 pieces
Well,
of
the
poster.
trouble with poster board is you can't see these lines.
Well, I know, but you can mark the straight lines, and you can stick your pen under that glass and mark it on the poster. You can transfer it, especially since you can see through the glass.
Yeah.
Okay, now it can be anything that's stiff enough. This is on the verge of being this piece of mylar. It's a drafting mylar, and it's been used. No use to us now, so we cut it up. It's on the verge of being too light. Poster board would give you a stiffer medium to work with. So anyway, you have to start someplace, and you can cut 3 or 4 pieces of poster board up at not very much expense.
I thought we brought all that poster board
Well,
up here.
it's in here. It's in the other room.
Okay.
And without cutting up a $30 piece of plexiglass, or 40 or 50, whatever the price is. So anyway, then you fit it up here. Let's see how it fits. And I've taped it in place after I've gotten my dimensions correct, and I've fine trimmed it with a pair of shears and make sure it just fits all the way around. You have to leave about a 1/16 of an inch of gap between the cabin roof and the windshield as it comes around underneath, and also across the tank cover in order to put your rubber trim on it.
Yeah.
So it has to be undersized, but first we need to get it to size. And we do it before we paint. If you wait till after you paint, I guarantee you're going to scratch your paint up. There's no way you can protect it well enough that you won't damage it some way. So we've got this approximate location. The next step, when I get it where I want it exactly, is to transfer holes in it. I'll lay that skin directly on the piece of glass, Lexan. I'll trace around it with felt tip. I'll cut it out with a pair of shears, making sure that I don't.
Really?
Yeah, it cuts easily.
Oh, it does?
Yeah.
I would have thought the edges would have shattered.
No, it's soft.
Okay.
That's what keeps it. It makes it pliable, and it stays that way. It doesn't get brittle.
I'm surprised.
So it's easy to work with. We cut it with a pair of hand shears, then we go back and dress it down with, when it's ready for installation, with a file and sandpaper going with the length
Any
of it.
particular kind of file?
Flat flat mill file.
Fine, medium, wouldn't be coarse.
Oh, it could be a medium, fine or medium mill file, and polish the edges. If you don't polish them, you'll get a crack in that area, or some area, normally. So we polish it with a file, running the length of the material, so it runs away from the grain, or smooth. Then we use a piece of wet or dry, fine wet or dry, and we finish polishing it. It'll polish up just like the outside surface, flat surface. And when you do that, you don't have any nicks in it, or saw cuts or anything that looked like it, little scratches in the edges. Then you can rivet it in place, put it in place, make sure it fits. Now, we allow enough material around the edges. Clothespins work well. In order, we use enough fabric here to get a good lap around the tubes. And again, the clothespins help hold it in place while you're working. We cover the bottom of the stabilizers first, so that any lapping material on the outside will be out of view on the bottom when we get through. So we cover the bottom first, then the top. Raw edges will come around underneath. Now once we get this glued good, and if it's set up, then we can shrink it.
Okay. Yep.
Okay, this is, again, the bottom of the surface. And the only exception to covering the bottom first are the wings.
You'd work from the back there, that'd be...
And we've got it glued all the way around and lapped under the tubing. We want to go around the outside and take all the wrinkles out of the fabric where it is glued to the tube. You just can't glue it as smooth as you'd like to. So you might as well forget gluing it extremely smooth and take it out with the iron, just like this.
That's amazing. How fast and nice that is.
And you don't want to over shrink it again now. You just want to take the wrinkles out, the bad wrinkles, and the slack. Now we'll cover, next step is to cover the top, lap it over about an inch here, to get a good bond surface, and then we'll shrink both sides evenly to keep it from distorting. Okay, ready? Okay, now we're going to punch these holes for the...
Now, what is that particular fitting you're freeing up there?
Well, that's the flying wire fitting.
So I don't see that one. I see the one by the hinge.
Okay, this one?
Yeah.
The front one is a strut, horizontal strut attach point. It gets a 3/16 hole. Now that's all you need. You just want to cut on the inside.
Beautiful.
This is the first area that's covered in the wing. I'll just go and do that. In order to keep from deforming these trim strips at the top and bottom of the wing panel. Are you running?
Yeah, I'm trying to follow you.
Okay, well anyway, these have to follow the contour of the wings. These are little angle strips. And you can pull them into shape exactly like you want to by heating this area. And when you get it heated enough, get all the wrinkles out and heat it up, then you stop.
Okay, go ahead.
Okay, the first thing we want to do when we start to cover the wings, of course, is to cover the aileron bay. But before we do that, we need to lay out 4 pieces long enough and cut them off and save them for the wing areas. The 2 tops, 2 bottoms. So we roll out the fabric, we cut it about 2 inches longer on each end than the actual length of the wing. Then on the leading edge, we trim the serving off, and that's the center line. We just trim enough of the fabric to get the serving off in a straight line, and that's the center line of the wing, leading edge. We'll have...
The serving is the prepared edge that the mill leaves on it so it won't unravel?
That's right. Now, we'll have about 4 feet of extra material on the back side, 2 to 4 feet. So we've cut inside the aileron bay, allowing 2 inches of overlap into the bay area, and then about 2 inches down the trailing edge, enough to lap over under the trailing edge. Any place that the fabric may touch another surface or a hard surface, it could vibrate and wear. So we're going to cover that with pink tape. And the way we do that is just run glue down it. And then, holding it in a straight line, we bond it to the surface. Okay, now since we've got all the ribs pop riveted down, or the fabric pop riveted, we're going to put a pink tape over the rib area. And we run it right down the center of the rib, glue it down. A little thinner on the brush will activate that glue. I see it's a little crooked, so you can pull it up, reestablish your lines if you need to. This is the rear window, and it comes stitched up like this in the shape of the airplane. This happens to be a cub window, or a pup window, cub type. And the fuselage is completely covered, the fabric shrunk, and before any filler or buildup is done, this is glued to the fuselage. That shows a window that is already installed. It's taped up so that it's masked off, in other words, so that the paint won't get on the glass. And the window is put in before that hole is cut, so the window is cut. It's covered entirely. Then this is glued on in the area that you need the window, or prefer the window.
Does that mean that it doesn't really matter?
No, you can have it up or down just a little bit.
As long as they do the same thing on both sides, probably.
Yes, I have it down just a little bit because the window in the hard window up here starts about this level. That's what I've done. Then you need to leave enough area on the front here to get a bond on this entire surface all the way around.
Now that should be raw cloth to raw cloth.
Raw cloth to raw cloth.
Right.
You let it dry very well. In other words, overnight, preferably.
Wow. Considering how your 5-second drying times have been amazing me, that's a long time.
Yeah, well, the reason being is that we're going to shrink it again in place we only glue from about here out. From about here out, we glue all the way around. Now, when we go inside and we trim it's all dried now. It's completely dried, set up. We go inside the fuselage and trim the fabric of the fuselage all the way around, right about this area.
Oh, so you haven't cut a hole yet?
I've cut a hole. Oh no, you glue it in place, because if you cut a hole there, the fabric will go in.
Right, okay.
And so you want to really press this tape down. Before you paint it, you go all the way around it, make sure it's pressed so that you won't get paint under it. Well, you trim it all the way around, remove that, then take some glue and very carefully and painstakingly glue the inside, bond it from the inside of the fuselage without getting glue on the window. After you get the hole cut, it's all dried very well so that it won't pull loose when you put heat to it. You'll see a few wrinkles in it, in the glass and around the edge of the fabric. And you take a hot iron and very carefully iron the edges down all the way around, just the outside edges, and that might take up all of the wrinkles.
Anytime you want.
We have 2 inspection rings in the fuselage. One is right here under the forward horizontal stabilizer support tube, and that leaves you access if you ever want to change the height of that tube. And one back here, just in front of the tail spring attach point, the front tail spring attach point. So when you cut this out, you can get right in there to the bolt that holds the tail spring. The next sequence of shots, we're going to show detail of the airplane as it goes together. I'll just pick up as I can and carry it through. We won't catch everything, but we'll get as much as we can. Here we're seeing the plane immediately after painting, really starting to look sharp. Here we have the front end of the prop flange with the bolts installed. You can see in the upper left-hand side the counterweight on the back of the prop. Here we have the oil pressure tube coming out of the oil pump, going to the filter, and also the pressure pickup going to the instrument, oil pressure gauge. This is the clamp holding the exhaust gas temperature probe into the exhaust stack. It's been trimmed down for size. This is a view of the carb heat box, the filter, the heat muff, and the hose that connects the two. It's rather close quartered. We're going to try to increase this in the future, but it is rather cramped in that cowling at this point. So here we have another shot of the coming out of the oil pump, the oil pressure line to the gauge, and the return line in the top of the engine coming back out of the cooler. Here we have the oil filter. It's pretty optional where you put it, but there's not much room in the engine compartment, so you have to fit everything before you start drilling holes and attaching. This shows the oil cooler, mounted to the firewall. This is about as good a spot as you can find to put it, and the little brackets that hold it in place. It's most efficient right here where it is. This is where the exit air exits the cowling. This is the opposite side, showing the line, the return line going back to the front of the engine. Also the bracket that holds it on this side. Two brackets. Really tight in these quarters. This is a cable inside the fuselage where you have the aileron cables. The wing is attached with an attach bolt at nearly center top of the picture. The carry-through cable, and then the pulley with the keeper on it. This is one of the aileron cables going down the side of the fuselage, showing the turnbuckle attachment, and it is safety wired. This is also an aileron cable guide or pulley with a safety keeper on it. Keeps that pulley or the cable from jumping out of the pulley. This is the front of the torque tube with all attachments. You've got your pillow block. On this particular setup we have a safety keeper on the pulley because it's not closely associated with the horn on the front. This is the rudder pedal on the right side of the fuselage attached to the cable. It shows a small spring that keeps it in the upright position. Doesn't take much to do this. Here we have a shot of the instrument panel. We have a switch. We've got the throttle T-handle, the choke, and the mixture control on the MMCB. You can see the fuel gauge handle underneath the dash there for the fuel cutoff. Now this is a shot of the mechanical brakes. We've got the landing gear off of the airplane, and I'm rotating it, showing how that it does actuate. It's a pretty simple, neat operation. It weighs a total of 1 pound. When you draw it up with your heel brake, boy, it really locks on. Okay, now we have the hookup for the magneto and the CDI unit. On this particular airplane we have a true dual ignition system. The switch on the left, and this is the back side, is for the magneto, and what we're doing is shorting the ground and the hot lead together to kill the magneto. This would be a normally closed switch. To operate the magneto, you would flip the switch up to open for operation. Now, the switch on the right is for the CDI, and what we've done is run a shielded wire, which is not necessary. It can be 2 wires, but we've used the shield for ground lead. And we've got that running to the battery, ground. Also, the battery is grounded to the airframe. So the shield is the ground. The battery is also grounded negative to ground. All right, our positive lead runs from the CDI unit through the switch. This is a normally open switch. You close it to make the CDI operate. So you've got a positive lead, and it goes back to the battery. So what you're doing is creating 12 volts across the CDI for operation by turning the switch on, or grounding it, or I beg your pardon, by connecting the leads. Now, what we're looking at is the top of the door frame as attached to the fuselage. there are two hinges on either door, or if you have a door and window combination on your airplane, you have two hinges on the window and two hinges on the door. This shows one of the hinges at the top of the door frame. It is pop riveted to the airframe to a 3/8 inch tube at the top of the door, and the lower half of the hinge is pop riveted to the frame of the door itself. A very simple installation, but effective. It's light and effective. Okay, now we're looking in the left-hand door of the fuselage to the forward part of the fuselage where the front controls are, front rudder pedals and front brakes. In the middle you see the little blue-green line running down, which is the fuel line that runs through the firewall to the gasculator. It's a very basic and simple installation. You see the rudder springs, rudder pedal springs, which keep the rudder pedals and cables tight. And you see the connection of the brake pedals to the cables, which connect to the rear brake pedals. Okay, now we're looking in the left-hand side of the fuselage, and we see the forward part of the torque tube, the front stick, and the connectors, the aileron connecting brackets that are mounted to the bottom of the horn on the torque tube. Now, this being the torque tube, we also show the elevator cable running around the front pulley and to the stick. There's a little portion of metal welded to the front of the torque tube, which is a keeper for the cable. So the cable pulley must be in close proximity to the little piece of, or the keeper. That'll keep that cable from jumping the pulley. Now, if you'll notice, we have castellated nuts in this area because we have a great deal of movement, and cotter keys, which keep the nuts from backing off the bolts. Safety feature. On the other side of the fuselage, you can see the front of the brake cylinder connected and how it is connected. Alright, now we have a shot of the brakes, and this is hooked up to the rear brake pedal because we're going to be operating the aircraft solo from the rear brakes, or from the rear seat. So we have the rear brake pedals, the rear rudder pedals, and we show how the cable is hooked to the rear pedal and how the master cylinder is hooked to the brake pedal. How it's hooked to the front, and on this type setup we have to have some kind of little reservoir to contain fluid. This is a simple T-pipe fitting, or a street L. This is not what I prefer to use. When we originally hooked the cylinders up, we had a clear plastic line that ran aft and up the rear of the rear seat back. Now, what happens with a clear plastic line of this type showing a fluid level is that it's very visible. You can tell at any time whether you have fluid in it or air in it. It works very nice. So you just connect that to the cylinder at this point instead of a little street L and run it out of the way down the side of the fuselage. It can be run forward too, depending on your preference. In order to prime these and get all the air out, you need to stand the cylinders upright. You have to disconnect it from the brake pedal, stand the cylinder upright, undo the nipple at the wheel, and pump with a little hand pump filled with red brake fluid until the lines are filled. Now, should you have a clear plastic line as we were talking about, you'll watch the fluid level go up that line. When it gets filled, you stop. Close the nipple. You've got a totally air-free system with no bleeding necessary. Where if you fill from the top, you have to pump, bleed, just like on a car. This is a very neat, simple system for bleeding brake lines. It works.
Yep.
Can I get one of you to hold on that strut, please? There you go.
I can't believe that. That's a brand new, never been on. Well, except on the test stand, but that was months ago.